check that. I got an answer, 24 tokens in 16.6 seconds. This is 23.4 seconds per token was the average. And I asked it, how many moons does Saturn have? The user is asking a factual question about Saturn's moons. This is a question where the answer has changed over time as, and again, maybe I have to, max tokens is 32. Well, maybe we'll just try it. This is the first, I've never spoken to, I have no idea what I'm doing. This is so, yes, we'll keep it simple here. Yes, send. Oh, that might be it. I may have maxed it out. It says it's still generating. Oh, you know what it probably has to do? It's generating a longer answer, and so it's going to run another batch of 32 max tokens. See the max tokens? I wonder if I set that higher. Look at that. Maybe I would have gotten all of the answer if I'd set it to 128. So I think it's still generating. So maybe if I just riff here a second, we'll get the rest of the answer, because it says it's still generating. So, yeah, that I was expecting that to take half an hour. And does Saturn, over time, as moons have... Yeah, come on. Show me the answer. All right. It's taken... So I think it took like 5 or 6 minutes. I thought it would take about half an hour, but 5 or 6 minutes to come up with an answer. And it says it's generating. Let me see what the GPU load's like. So it's maxed out on 102 gigabytes of RAM, because that's going to be all the hot experts are going to be cached in CPU RAM. 24 gigabytes of GPU RAM. And we're running about 10% occupancy. So, we are I/O bound. Now, you go, oh, okay, well, this is slow. That's not useful for anything. No, we're not done yet. This is just the 1.0. It's not even the 1.0 release. So on the two computers over here, I have two other features coming. The spherical quantization stuff is going to achieve, I think, about 2 to 3x compression in real time of the Kimi-K cache. And once I get that merged in, which might take me a minute or two, so we'll see, then I think I'll get 2 or 3 times faster. It calmed down. I wonder if that means I got an answer. Let's see here. Where was it? I'll go back to have been. It got, so it was at have, and it's got to been discovered, question mark. And it says ready. Yes. So I'll just say yes. I'm not going to pre-filling. Oh my God. So anyway, I'm saying that. So I've got the spherical quantization coming for the weights in KV cache. Now, Kimi-K's weights are already highly quantized, and it's supposedly trained to be quantization aware. So that means that my spherical quantization probably won't help much with the weights. But what we're probably really carrying a lot is this thing, as the conversation grows, is a lot of KV cache. And the KV cache, I think I might get at least 2 to 3 X compression on, because those are 16-bit floats, and those are probably going to compress real well. So I wouldn't be surprised if that got us maybe 2 or 3 times more performance. And then I have tensor striping coming, and the tensor striping, you can see this terrible occupancy that we have here, right? We're at 25. Wow, just 20% occupancy is crazy. So our goal, we're not reaching our full streaming potential here until we get close to 100% occupancy, which technically should be nearly impossible. But I've had Kimi-K. Sorry, I've been up for 2 days straight. I'm a little blurry here. Kimi-K 2.7 code was running on this machine when I was testing before Kimi-K3 came out at about 80% occupancy. So a lesser model by a lot, that was about 600 gigabytes a model, I think, was running at about 80% occupancy before I'd added any additional features. So I think that once I get the striping in, so what'll happen with the striping is, even though I/O is maxed out, it's still bursty. And so by striping the layers, the Kimi-K layers, I believe that I'll get even more, capture more of the I/O throughput from the NVMe drive than I have been, and I think that might get us up another 2x. So I predict that we might be in the ballpark of another 6x in performance, and it's at 15.5 tokens a second. So I think that would get us down to about 1 to 2 seconds per token. And at that point, you're almost able to chat with the thing in real time. And this is just, this optimization is 48 hours of work. So is it likely that I will be able to get a Frontier model, coding model, running on this laptop at chat speeds? I think given a few days, I think I might be able to hit it. I need some sleep, but I think we're looking very good here because the additional tricks we have up our sleeve for getting the speed up's looking real good. So I think at the point that you're able to chat with Kimi-K3 in real time on a gaming computer, you're still look at it, pre-filling all the experts. Oh my God, it's the amount of computation and data moving going on here in order for this to work is almost beyond comprehension. It is a real achievement in streaming to be able to do this. So wish me luck. Once now I want to open source this, get these libraries up. The trouble is that they take a lot of testing, and I've got 6 computers, and it's just such big sets of data being involved that I'm going to leave them running for overnight. Oh, there we go. And the what? Oh my God, the suspense is killing me. You just saw. So I said yes, question mark. You just saw how long it took to get to the user. Oh my God, stop wasting tokens on saying the user. Oh no. It's just my precious token budget. And it's running at 116.4 tokens a second. So now 89.9. The user asked, don't repeat the frickin' question. Just answer the question. So it's slowing down, and the reason it's probably slowing down is the KV cache is building. It's going to quote me 66.2 tokens per second. So the KV, as we talk to the model, and it's going around and around through the streaming layer, it's building up this KV cache. And the KV cache has to be applied over and over again at an exponential number of times per token. So it's really piling on now. And that KV cache is all 16-bit, as if I understand the Kimi-K3 documentation. So if I manage to spherical quantize that down in size dramatically, we should get a big speed increase out of it. And that combined with the tensor striping should get us much better I/O utilization. And we might be able to sit here and chat with the thing by the time I'm done. And that's pretty amazing. And the thing is that, yeah, it's kind of silly going, well, this is kind of slow to be practical on a gaming laptop. But this is the first time it's ever been done. People are going to make better computers. Once you're running Frontier class stuff on toy home computers, that's a whole new world. There's implications for this for the data center as well, because as novel, as cool, I did this for consumer devices, but if you think about what it means to deploy this architecture, a Cylon streaming architecture in a data center, what it means is all that incredibly expensive VRAM that nobody can get a hold of, you can replace it all with NVMe drives. And NVMe drives are cheap. There's no shortage of those. And they're bigger than NVRAM, which means that the KV cache can be much larger. And that combined with the striping, the tensor striping, and the spherical quantization of the cache will shrink the cache dramatically, which will exponentially speed it up. And the net result should be that you can do some really heavy, you could just pour tons of tokens into this thing, let it chew overnight, and it'll haul a bunch of tokens through much lower cost computers than the kind of monster NVIDIA machines that they have to use for inferencing today. And so, the idea of, say, a large corporation being able to say, we just want to dump all of our documents in, let it run for a week or two, and ingest all of our corporate knowledge and so forth into an AI model becomes practical and, an order of magnitude cheaper in this architecture than trying to run it in a giant VRAM supercomputer. And latency you can put enough NVMe drives in parallel to feed the GPUs at full speed. They're just going to be high latency, but you don't care about high latency if you're not trying to chat with it in real time. You're just trying to ingest a huge volume of information. Then that's going to be a much lower cost way to apply AI to just big bulk bodies of data. So not only is this a really interesting solution for being able to run frontier AI on a home computer, and I deliberately ran it on this laptop just to be as absurd as possible. I didn't even think of trying to run it off the thumb drive. That just happened. But the very idea of being able to run a model like this on a consumer computer was meant to be the big demo. That's what I built it for. But once you've got it working and you've put all the technology together, you quickly realize that this is just a cheaper way to run AI. And right now, I'm running it on the CUDA stack because I'm testing. But I have the Vulkan and DX12 stacks, which are faster. Now, it's not going to matter because this is I/O bound. So the fact that the Vulkan stack, I think, is 1.5 times faster on this GPU, this NVIDIA 59 GPU than CUDA isn't going to matter because we're I/O bound. But when you get to a data center, if you say, I'm going to line up a bunch of AMD or NVIDIA GPUs, if you still need to feel like buying them, which you have choices now, because Vulkan is faster, and I bet you when I run it on my AMD AI machine here, it will get some interesting results, maybe by tomorrow. You're going to see, you're going to go, well, we can run giant sort of corporate scale AI workloads or compute programming tasks in the cloud for, on the order of maybe 1/10 the price of what these AI clusters cost now. So I expect this will change a lot of things. So it's pretty exciting. Followed up with yes, question mark. He just answer the question. Oh, God. Well, obviously, you can see it speaking English. So the world's smartest AI is a little pedantic, but you're sitting here in real time watching it chat, and you can see the rate at which it's generating tokens, 28.8 tokens. It's actually speeding up. Oh, because the AI said there's a whole pre-fill to warm it up, and now that it's warm and the cache is tuned, what this means is that the AI model is running 890 some expert models, but the Cylon cache is hitting the same 16 so frequently and so predictably that even though the KV cache is massive and compounding, the average tokens per second or seconds per token is dropping anyway. So the combination of streaming and caching without quantization and without tensor striping is actually working pretty damn well. I have to say I'm a little surprised it's working this well because I was anticipating that it would be hopelessly slow to even approach doing this in real time. But given how well it's doing at the moment, I am quite optimistic that when I fold in these other elements of Cylon and get them all working together, that I may be, before the week is out, I may be chatting away with Kimi-K3 in real time on this laptop. So, wish me luck. It's working. There it is. Chatting in sloth time. It seems like they're waiting for an answer. Yes, oh God. Anybody remember the first episode of Zootopia where the fox and the bunny go to the DMV to get a driver's license and the sloth's running the thing? Kind of having that experience at the moment. Seems like they're waiting for an answer. Really? Do you think this is 1.4 trillion or 2.8 trillion parameters, and this is what we've come to? The AI's really working hard overtime to figure out. And again, to be clear, this model has not been quantized. I haven't quantized it. I'm not cheating. I didn't turn it into a guff file. It's not running in llama and with half its IQ gone. This is the full brains of Kimi-K3. It's answering very slowly. Seems like they're waiting for an answer, perhaps thinking, is it done? No, it says ready. So that's the end of its answer, ready. I wonder, now I'm asking for it now, because I don't know what, this is the first time I've done this. We'll just increase its tokens. Just name a number, exclamation point. See if I can just get it to just say a number. Now, actually, I forget how many moons Saturn has. Let's just look it up on Google. Does anybody else appreciate the irony of doing that? How many? Oops, here we go. Where'd it go? Oh, good. Frickin' iPhone. Anybody hate the new iPhone interface? How many moons does Saturn have? And you have to 2026 because it changed. They find more moons around Saturn. 274 confirmed and recognized moons. All right. Does Kimi-K3 answer the correct number of moons for Saturn? Or do they have count a different number of moons in China? Actually, that's a funny question because what data set was Kimi-K3? Hopefully it was trained on Google, in which case the answer is 274. All right, we gave its max tokens. Let me see if it blows up the model. I just batching. We're now at GPU 93 gigabytes. I still got a little elbow room here for that KV cache, which is spilling into CPU RAM. 116, shared GPU memory. 116 gigabytes of RAM. 19, but it's still running around close to 20% GPU utilization. I can't believe I'm witnessing this. I'm pretty. I love the singularity. It would have taken me, I've made a lot of amazing streaming technology over the decades. Every time you have to raise venture capital, hire armies of smart people, spend a decade of your life building a company, and I have never been able to just sit in my barn and ideate and produce code like this. I think I get yelled at, but I was last big commit I did to the Playcast code base was on the order of 207,000 lines of code in a week. That's my record so far, but I think I'm getting faster. So, what is that, 1,000x kind of the production of, I would say, commercial grade code? One of the things that's letting me doing this, of course, I'm using Cursor and I'm using a lot of Claude, Fable 5 to do this. Don't get me wrong, it's brilliant. But one of our engineers at Playcast came up with a thing called a phaser plan for Cursor. And we were fighting, AI slop was a real problem. The AI would happily just spew a lot of crappy, disorganized code, and it was driving everybody crazy. So one of our engineers came up with a thing called a phaser plan, which is a MD file in Cursor that does an amazing job of producing negative tech debt, so that any code that you generate, it not only goes through and reviews everything it generates, but reviews all the previous code it's replacing, generates whole test automation suites, automatically runs the test automation suites, so that now when I spew out 200,000 lines of AI-generated code, it comes with comprehensive test suites that automatically get deployed to our build system. One of my ex-Microsoft friends has founded an AI company that's building AI build systems, and he had a bunch of, it's called Autark. His company's called Autark. You probably haven't heard of it yet because they're still in stealth mode, but he came by and helped us rig come on. Just name a number. Just a number, please. And now we're hitting 220 seconds per token. Maybe it's reaching some extra experts to come up with the number. I wonder if I could tell it to stop starting every sentence with the user. So anyway, these phaser plans remove or scrub tech debt out of the code being generated and the code that it's merging with, so that now when a crazy engineer like me, does a merge with a 200,000 line code commit, the overall code base comes and we automatically deploy the test suite cursor generated and the benchmarks and the quality and the code reviews, because we use GitHub BugBot and does security reviews and everything. So I feel like the quality of our startup code has gone, even as we're producing 100 to 1,000 times the code that we, humans used to produce just last week. Feels like that the quality of our code base is shooting up, owing to the adoption of these phaser plans. And I'm pretty sure we're not the only ones who are doing this. Other people, smart people out there, are figuring out how to get their build systems, how to use the AI to contain the vast amount of code that it can produce without creating a total mess of AI slop. So I think we have negative AI slop going on these days. The user is asking how many. Yes, it just keeps. I'm almost wondering if Kimi-K3, the whole hype around it, is a gag, and really we're just running Ractor from the 1980s, and all it's going to do is repeat the questions I ask without ever answering, and see how long I do that for at 41 seconds per token. User's asking how many moons. Come on, just a number. Saturn, yes. I gave it a max budget. I gave it 128 token max budget, and it still hasn't blown up. Let me see. See what the. Oh, look now. Oh, interesting. And see, if you look over there on Drive C, you see the green section of Drive C. I'm going to page over here. So I'm using direct storage, which I created and gave to NVIDIA many years ago. And NVIDIA licensed it to Microsoft and shipped it with Windows. And what direct storage does is allow the GPU to talk directly to a modern, fast NVMe drive right over the bus, the PCI bus, with no fat operating system and no bulky drivers slowing it down. So we're maxing out the I/O rate. I think this NVMe drive hits about 6 gigabytes a second. And I ordered some 12 gigabyte second NVMe drives. I'm going to put them in parallel to really see, and on a PCI 5 bus, to see if I can get the occupancy of the GPU up to nearly 100%. I think that's going to succeed. So, yep, that's not going to work on a laptop, but this is just making a point. But once I build a box that is configured, just a gaming box, I'm going to do it off the shelf. I'm still going to go, what is something that somebody could just build at home with off-the-shelf parts? I think I'll be able to get the occupancy up above 50% from the looks of it. And like I said, I think we'll be having real-time chats with Kimi-K3, within the month at this rate. The singularity is moving incredibly fast. All right, I'm not going to sit here and watch the thing repeat what I'm saying to it for the rest of the evening, because that's going to drive me insane. And they're getting impatient. I think it's listening to me. And they're getting impatient. Oh, my God. Yeah, I think this, over at China, maybe at Moonshot, they're just having a huge laugh, going, how many people are wasting their time with a model that's just going to repeat the question they ask after enormous media hype that it's the smartest model ever. Man, if it tries coding like this way, I'm going to wring its neck. I'm sure it knows how many moons Saturn has. I really don't want to sit here and wait for it. It's just a number. Just the number, say 274. Just say it. Just expect 30 seconds per token. So I don't know, if you're not a total AI wonk, you may not know how a KV cache is actually applied to a model. It's spilling over into this NVMe drive, and every single token, it gets folded over, so it produces a new set of KV caches. And each layer of KV caches, for every letter or token that's coming through this thing, has to be reprocessed by the entire AI model. All 93 layers, and whatever the expert layers are, compounded per token. And so the fact that we're still running at a kind of a flat seconds per token rate is a real testament to how efficiently this is running at all. So that is but it's clearly not going to give me a direct answer. Look, if I get a straight answer out of it, I'll let you guys know. But I think you get the point. There it is. If it were Claude or something like that I had these modeled for, I'm pretty sure I'd be running it just fine right now too. So I think give me a week or two, maybe a little more, and maybe we'll be talking to Frontier models on our gaming laptops in real time. I am now optimistic. I thought I was going to be half an hour to an answer, and it is actually performing beautifully. So we'll take that. Calling it a win. You all have a great day, and I'll probably be streaming some more tomorrow.